Let's take a look at the relationship between the segments of a chord when we have two chords that intersect each other in the interior of a circle. So we can see that when these two chords cross, they divide them into two parts, but they're not equal parts, but they're not random parts either. They're controlled kind of by that point in the middle, and you'll sometimes hear these referred to as power of a point problem, because that point there in the center really is an important point to figuring out how these chords are going to divide themselves up. The relationship we have here is that each piece of the chord, so if we look at the chord EF, we can look at the two pieces, EG and GF. If we take the product of their lengths, it's going to be equal to the product of the two pieces of the other chord. So if we look at chord DC, we can have segment DG multiplied together with GC. And that's going to be our first formula of the day. So we can just multiply each piece together, and we're going to have an equal amount for both chords. So let's look at an example that would use this. Real quick, if we were to just say that EG was 2 units in length and GF was 6 units in length, we can see the product of those two pieces would be 12. So if I were to tell you that DG was 3 units in length, well, we know that the product of DG and GC should also be 12. So this one we can almost just use mental math for. We would know that GC needs to be 4. Now if we were to take a look at something slightly more difficult, looking at example 3 from your handout, looks fairly similar, but when we start to fill in the lengths here, it tells us that, sorry about that, it tells us that HP is 6, that PJ is 4, and LM, that's the entire chord, is 11. So if we're trying to find LP and PM, let's call one of those X. Doesn't really matter. I'll call PMX. Which means that LP is the remainder of that length. So if it was 11 and we've already got X taken up, this must be 11 minus X. So if we're solving for PM and LP, it's pretty obvious here we need to solve for X. So let's go ahead and set up an equation. Using the equation that we just came up with, we know that HP multiplied with PJ should equal LP times PM. If we start substituting in the values that we have, so we know HP was 6, PJ was 4, that should be equal to LP, 11 minus X, times PM, which we called X. We multiply together both sides. We get 24 is equal to 11x minus x squared. Let's move everything over to the left side. So we'll add x squared to both sides, subtract 11x from both sides. 24 stays where it is. And we see we have a nice quadratic equation. Hopefully this one will factor. Let's see if it does. We need two numbers that multiply to 24. Add up to negative 11. How about negative 8 and negative 3? So the two values for x are 8 and 3. If we just quickly double check, we can see that both of those give us positive segment length, so they're both valid answers. There's our solution. We still need to answer the question that was being asked, is what is LP? LP would either be 11 minus 8, which is 3, or LP will equal 11 minus 3, which is 8. So there's two lengths for LP. We could also need to find PM. Since that's just X, we can say PM is equal to either 8 or 3.